Hi everyone, welcome TWF community. It's great to be here again. My name is Michał Grygierzec and I work for Infusion as a consultant. And this presentation is about functional programming from F# perspective. But before we start, let me ask you, have you heard about F# already? And oh yeah, I can see some hands, great. And how many .NET developers do we have here actually? .NET developers, don't be shy. Okay, less, so it's interesting. I will start this presentation with a very brief overview of current state of functional programming in software industry. Then I will shortly describe the history of functional programming and F#. I will mention about my motivation to learn new language and paradigm. And after that, I will discuss some interesting data, which will hopefully interest you and encourage you to learn F# too. Why not? And the last point will be a small demo. Functional programming is extremely popular, is getting extremely popular these days, especially it's emphasized by multi-paradigm languages like Scala or Swift, and F#, why not? There is also a pure Haskell, purely functional language. There is Clojure. Actually, yesterday we saw some Clojure script in action. There is Erlang. Previous presentation there was mentioning about Erlang, and very fresh Elixir, for example. And very interesting language, actually, Elm. It was created for functional front-end development specifically, and in my opinion, it will take over React and Angular soon. However, only time will tell. We will see. And short history, background, functional programming is quite an old concept. In early 50s, when Lisp was born, it got popular. And interesting fact, C programming language, for example, was created in 1972. And F# is more than 10 years old now, created by Don Syme from Microsoft Research in Cambridge. And open sourced since 2010. It is truly cross-platform. You can develop application on Unix, Windows, Linux, FreeBSD, etc. You can read more about it on fsharp.org official page. And when we are speaking about software development, I believe that all people involved in software projects want to deliver the best possible product. And my motivation to learn F# and functional programming was to broaden my programming horizons, boost my productivity, deliver safe, reliable, robust product, and have fun doing this. And do not worry too much about sudden runtime exceptions or errors to have peaceful mind, right? That my application will not blow up. So that was really important also. And there's one more thing. Let me quote a famous American computer scientist, the first recipient of Turing Award, Alan Perlis, who said that a language that doesn't affect the way you think about programming is not worth knowing. And actually, after years working with imperative, with object-oriented languages, when I discovered functional programming, first in JavaScript, then in F#, it was like a real eye-opener for me. And I really did enjoy it very much. So let me take you to a small tour about functional programming, fundamental concepts and features. And F# is a multi-paradigm language, as I mentioned earlier. It is functional first, however, contains some imperative mechanisms, supports object-oriented programming, especially for interoperability with C#, has great asynchronous and parallel programming models, and even agent-based, simple agent-based one. So yeah, it's like a Swiss Army knife in MacGyver's pocket. Awesome. Let's start our small tour, functional tour, with type inference. which is a mechanism used by compiler to deduce or figure out what types are used in expressions in our program. Very simple example. You will not see here any single type. Everything is inferred by compiler, and it is very helpful for us. We do not need to actually carry too much about this. And sometimes explicit annotations will be needed, especially when dealing with object-oriented world. Unfortunately, we cannot avoid it in .NET. Yeah, but it's rather minority of use cases. Next stop is immutability, which basically means that once defined binding cannot change. There is no such possibility. And it gives us priceless, dead sure predictability, and generally makes our life easier. However, small mental shift is needed, especially when you are used to mutable data structures. So again, very simple, trivial example, we bind value 7 to X identifier. When we try to modify it, we cannot bind it to X again. We need to bind it to a new identifier. Very, very simple idea, but very powerful in more complicated scenarios. And next stop is carrying, which means transforming a function with many arguments into a series of nested functions, each with only one argument. And all functions in F# are auto-carried by compiler. Again, let's see some simple example. We have add function, and we can rewrite it using lambda expression, and then we can transform it further, and we end up with two nested lambda expression. First, which accepts X parameter and returns another anonymous function, which accepts Y parameter, and finally returns the sum of these arguments. Yeah, it is a very powerful technique, and actually you will find carrying over functional programming languages, actually. So very, very important thing. And naturally there comes partial application, which means passing to function less arguments than it originally accepts. As a result, function returns another function which accepts remaining parameters. Why is that useful? Again, small example. We partially applied add numbers function, and then it has some specific new meaning for us. We can reuse that function in some new context. This is very, very trivial example, but there are situations then it is extremely, extremely useful. And it is very heavily used in functional programming. And next stop is higher order functions, which are functions which either accept function as the input or return function as an output. As simple as that, but also very important technique. Here, very trivial example, calculate accepts f, which is a function. We can pass function as a values, as a common values. And we just make a small calculation with plus and with multiplication. And it works. And this is, in my opinion, a killer feature of F#, used broadly in functional programming. Pattern matching. You can find it in many languages and even in multi-paradigm languages, which will actually adopt it soon, like C#, or there is a similar concept in JavaScript, I mean ECMAScript 6 to be specific, called destructuring. So let's see a simple destructuring example. We have the tuple, or rather triple, and we bind in one single line first and third value, and we ignore the second one. Another example it also works, for example, for lists of integers. Why not? There is an A, B, and rest identifiers. It works pretty well. And at last, actual pattern matching. And you can see match expression here. We can actually use any set of patterns we want. And interesting thing, compiler will warn us if we miss something or even return error depending on our configuration. So this is very, very nice and very useful feature of F#. And small things matter, but this feature is extremely useful. Structural equality helps us to easily compare values, a little bit more complex values, or even very complex one like records, when there can be a lot of fields. It's very useful. And the last stop, option type, which is a union of two cases that we either have some data or we have nothing. And in F# it is defined by so-called discriminated union, and you can see that some case has a generic type '(a), because that can be anything, right? So a simple example which shows pattern matching, how it plays well together with option types. So we have some int, we multiply it by 2 when it exists, otherwise we return none. Very, very concise, very nice. And as I promised, some interesting vital statistics will be revealed now, collected by Stack Overflow in developer survey in 2016. So first category, most loved technology language, F# in the 3rd place, and top paying technology United States, F# 4th place, and top paying technology worldwide. What do you think? No. F# is in the 1st place, interestingly. So now I can see that spark in your eyes, gentlemen in the 1st row. If you want to learn functional programming and F#, I do recommend wholeheartedly the famous F# for Fun and Profit blog by Scott Loshin. It is the best programming blog ever. And we're running out of time, so summary. F# is a multi-paradigm, functional first, object-oriented language, very flexible, powerful, and it helps us write better code, and the code will be a pleasure to maintain and extend. And hopefully you will have the same experience as I. Actually, if you want to count out the joy of programming again, F# will be a great way to start. And a small demo, last point, it is actually the topic of the workshops tomorrow, web app written entirely in F#, both client-side and backend-side. It is even the build script which you can see running is written in F#. Firstly, it builds server-side. Now it compiles using Fable compiler, transforms F# to JavaScript, and then using Webpack, it bundles the application. I'm using React.js there, and it fetches data from Star Wars API online, so it's great. And as you can see on the right-hand side, everything is in F#. So that is all from my side. I would like to say a huge thank you to my wife. Without her support, I would have never finished this presentation on time. And I'd like to finish by thanking you all for your attention and interest. I hope you enjoyed the presentation, which, by the way, was built with F#. And have a great time on the TWF conference. And I wish you all the best with functional programming. I will be pleased to answer all your questions in the lounge later. Thank you very much.